Hello, my name is Krupa, and I'm an assistant professor of mathematics education at Montclair State University in New Jersey. And I'm here to talk about disciplinary literacy from a mathematics literacy perspective. And a lot of people say mathematics and literacy together. And yep, we're going to talk about both and how they're interrelated. So mathematical literacy used to just include numeracy, which included a focus on quantity. And it's expanded now to include quantitative literacy and spatial literacy. So we're going to talk about some of these ideas today. The term became more prominent in the late 1980s when the National Council for Teachers of Mathematics introduced it into its standards for the first time. And in 1999, the Organization for Economic Cooperation and Development defined it as an individual's capacity to identify and understand the role that mathematics plays in the world, to make well-focused judgments, and to engage in mathematics in ways that meet the needs of that individual's current and future life as a constructive, concerned, and reflective citizen. So from that definition, you can see it's a lot about your place in society and how mathematics is used in everyday life. It's really important that when we're talking about mathematical literacy, it's focused on relating to the real world and how you can use mathematical judgments and arguments in everyday life. The four major modes of communication and language are speaking, listening, writing, and reading. And all of these should be encouraged in mathematics classrooms to build mathematical literacy. It's equally important to be able to do all four. It's important that you can speak mathematically, understand what others say mathematically, write mathematically, and read mathematical texts. Students should have opportunities to engage in all four of these to develop their own mathematical literacy. In 2001, Thomas Romberg said, "Considering mathematics as a language implies that students not only must learn the concepts and procedures of mathematics, but must learn to use such ideas to solve non-routine problems and learn to mathematize in a variety of situations." So it's not only important to be able to read mathematically, but to be able to solve problems that are posed and use mathematical reasoning to work through different situations. In the case of reading mathematically, it's important to realize that some mathematical terms have different meanings than if you read them in a social studies or historical context. For example, the word radical has a completely different meaning in mathematics than in other disciplines. Even within mathematics, a word like median means one thing in geometry and another thing in statistics. So understanding mathematical context is important. Reading mathematically can also be challenging because math has its own language, its own set of symbols, operations, and equations. So if a student reads 5x, it's important that they realize that's 5 times x. However, if you see a 2 and a 1/4 next to each other, the intended operation is 2 plus 1/4. So reading mathematically can be challenging in certain situations because the context can change. There's 8 competencies that are needed to promote mathematical literacy that DeLange pointed out. One is mathematical thinking and reasoning, and this is the ability to pose questions, knowing what kind of answers can come from mathematical questions, being able to make conjectures and gather evidence, a lot like the inquiry-based processes we've been talking about. Mathematical argumentation is the second competency. So being able to articulate a mathematical argument and explain it to others, creating and expressing mathematical ideas and understanding what proofs are, even if they're informal. The third mathematical competency for mathematical literacy is mathematical communication, and this is being able to express oneself in a mathematical way and being able to critique and understand someone else's work. The fourth competency is modeling. This is very prominent in the Common Core standards. It's its own mathematical practice standard. And modeling is being able to translate into reality a structure that you read about, interpreting models in terms of real-world context, and being able to reflect on the models that you create. The fifth mathematical competency is problem posing and solving. And this ability to pose and solve mathematical problems is the primary goal of being mathematically literate. It's posing and formulating, defining and solving problems in a variety of ways. So it's important that we engage students in entry to tasks that have more than one way to solve them. The sixth is representation. It's important to be able to translate between and among different representations, being able to create their own, and construct alternative representations. The seventh is symbols, and this one's really important in mathematics, both in writing and being able to read. There's lots of symbols, equations, operations, and it's important to be able to move flexibly among them. The last one is tools and technology. And in this ever-growing technological world, it's very important that we can harness the power of technology and different tools and manipulatives to solve mathematical problems. In some literature, researchers think that beliefs and confidence is another important step in being mathematically literate. So having the confidence in one's own ability to do mathematics and to appreciate the role that mathematics plays in our society. The language of mathematics is often confined to what occurs in classrooms, so instruction that promotes these competencies is critical to encourage students to become and build, or to become mathematically literate and to build on their mathematical literacy. Now I encourage you to explore the inquiry-based disciplinary literacy lesson for mathematics below. You will see students engage in a mathematical task and harness the power of technology to build their mathematical knowledge.